Okay, so hexadecimal number system records the number that you have in a hexadecimal system are the digits that you have in a hexadecimal system are not between 0 and 9 only. They are from 0 to 16. In order to encode 16, because if 16 is 1, 6, it's a combination of digit 1 and 6. What they use is they use alphabets, A, B, C, D, E. So A is 10, B is 11, C is 12, and so on. And that's how they set up hexadecimal system. So the question is asking you guys, question 3.8 is asking you guys to set up a flexible number system where number of the base can be between 0 and 1 and 36. And you give any number and it converts that number into decimal number system. So let me start sharing my screen and tell you one way how we can solve it. So I'm assuming all of you can see my screen. Open the chat so that I can see your conversation. Okay, perfect. So basically, I want to enter a number. Let's say something like this: 3, 4. Let's say W, and let's say I say that this is in base 36, and I want to convert it into some number. Let's say this is 5, 6, 7, 8 in base 10. So that's the question. That's what the question is asking you. You give any number and its base, and you convert it into a decimal number. Okay. So let's look at what do we have in the question. So we'll have a number. Let's say to start on, we take some number which is hexadecimal because we know what to do with hexadecimal number. So let's say you have this number, and let's say the base is 16 because we know that the base for hexadecimal system numbers is base 16, and now we need to convert it. What should we do first? So how should I tackle this problem? Okay, those of you who have tried it and have worked, by the way, mathematically, how do we do this mathematically, by the way? Let's say I ask you, forget about coding. If I'm given this, how would I convert this mathematically into decimal number system? So basically what this means is, what the above means is that the number is basically this: 3 times base, which is in this case 36, power 2 plus 4 times base, which is 36 times 1 plus W times, where W would be a number, we would convert it into a digit, times 36 power 0. That's how we convert any number from any base into a decimal number system. Okay, so basically we have to actually implement this. So what are the things that we are doing? First, we are dividing this number into each digit. We are extracting each digit of it. That's the first part. So let's do this. So I can do this. I can say that, let's call it num string. I convert my number to string. And then I can just say that digits is I for I in num underscore string and print digits. Let's see if that does the trick. Okay, it will create an error. I have to, so because I have digits which are characters as well, I have to make the number a string because I'm giving it an A. A is not a digit, so I have to make it a string by default. Okay, so this is this now. Okay, so I have done the first part, which is I have all these numbers, these digits. Okay, what is the second thing? What do I need to do now? Once I have the digits, what is the second step? What do I need to do? By the way, if at any time you don't understand something or something is confusing, please ask questions. This is for your benefit. You can take some time on it. The thing is to understand the tools available to us in Python to manage these types of problems and logically construct this algorithm. So yeah, what should I do next? It doesn't have to be, any answer would work, okay? Multiply each digit by the base raised to the power, okay? That's true. But one thing that I would like to point out is that if you look at the power of the bases, so the first digit gets the maximum one. So basically it starts from the right-hand side, the power is 0 and then 1 and then 2. Would it be nice if I flip this? Do you think it would okay, get the count of digit first. That's also a good idea. That's something that we would need. So let's do this. So let's call it len underscore number. This is length of digits. Okay, I have this. Now, as I said, because you can see that W is multiplied with 0 power of the base, 4 is multiplied with first power of the base, and 3 is multiplied with second power of the base. So it seems like this is assigned a power 0, this is assigned a power 1, and this is assigned a power 2. And if we use enumerate, it's better to flip it. So I will try to flip this. So basically what I want to do is I'll call it digits underscore flip, and I'll just take the digits and I will do this. What have I done here? So basically this is called array indexing and slicing, or list indexing and list slicing. Just to give you guys an idea, let's call it, let's take a list and let's give it a number from, let's say I want to take some elements of this list. Let's say I'm asked to get the second to last, start from the second, go up till the last element of the list and get all these values. So I can do something like this. You can say, okay, go from second, go till the end, and take all values of this list, okay? So this will start from the second element, go till the very, okay, so if you want this, I think this will get all the values, yes, okay? Now, this is the starting point where you want to start selecting the values. The second element is the ending point where you want to end elements. And the last point, is, the last number is the step size that you want to. So if you want to take every element, you will put 1. If you want to take every second element, you would put 2, and so on. So you can extend it. Now something interesting happens when you put a -1 here. So if you put -1, it considers the array in the flipped order. Okay, so basically it simply flips the order. If you want to, let's say, start from this element, the last element, and go till the first element, you can do something like this and give it 1. Now it would not take 0. It would take all the other elements, but not 0. In fact, not the first one and the 0. Okay, so if you do this, it will not take the first element and every other element if you give it 1. So basically it's flipped. This is, the first element would be the leftmost element, the rightmost element that you want to take, and this would be the leftmost element that you want to take. So basically just doing this flips the array. So the array is flipped. Now, I have flipped the array. I have to go over each element of this list and multiply it with the base. So apparently I would have to use something like a for loop. So I can say that for, let's call it n, and well, what is it? Enumerate digits underscore flip. So enumerate basically returns the elements of the list, but also numbers them, also returns their index. So let me just print this. It will give us an idea of what's going on. and 12. So you can see it returns 0, which is the first element of this from the right-hand side because I flipped it, and returns its index, which is 0. Then it returns A, which is the second element, and returns its index 1. Okay, everyone is clear so far what I've done?
Yes.
Okay, perfect. I want to see some more yeses in the chat before we move on. Excellent. So now comes the interesting part. So the interesting part is you can have two things in your in your numbers. You can have numbers which are between 0 and 9, or you can have characters which are between A to Z. So how do I do it? How do I, of course, for numbers, I would just assign them from 0 to 9. The digit corresponding to numbers would be 0 to 9. The number corresponding to A to Z would be 10 up till 36. So how do I do it? Any ideas? How do I convert an A to mean 10, a B to mean 11, a C to mean 12, and so on? Okay, I can make a dictionary. Okay, that's fine. But that would be too much typing. So I'll give you a better technique. So in hexadecimal, in ASCII number system, all the alphabets are together. So A, B, C, D, F, G, their codes, they are right next to each other. Similarly, all the digits, they are right next to each other. And if you want to access the ASCII representation of a character, just put ORD and give it, let's say, 0. So 0 is 48. The ASCII representation of 0 is 48. The ASCII representation of 1 is 49, and so on, up till 9. Okay. And similarly, for characters, the ASCII representation of A is 97. For B, it would be 98, and so on. Okay, how can I use this? I want to use this representation to avoid using a dictionary, to use this in an effective manner so that I can convert them into digits by using these ASCII representation of the characters. Anybody wants to make a guess? So I'll have if statement. I'll have if for digits and then another if for characters. So what should I do for digit? Yes, that's good. That's exactly what we would do. But one other thing, we have to make it separate. So I will say that if order of my character, which is well, is greater than or equal to order of 0, and order of my well is less than or equal to order of 9, then I know that it's a digit, right? It's between 0 and 9. I'm saying that the order of well is greater than or equal to 0 and less than or equal to 9, which means that it's a digit, right? It's a number from 0 to 9. Okay, then what do I do? Then I treat this as, I'll call it digit well. So digit well, treat it as a number. And how do I treat it as a number? I will simply say order of well minus order of 0. Okay, this would, now digit well would contain a number between 0 and 9 for all the digits. Now, looking at this, what should I do for alphabets from A to Z? What should I write here? So this should be order of well. What should be it greater than equal to? A, exactly. It should be greater than equal to order of A. By the way, for anyone, if there are questions, please ask them. Don't be shy. There are no bad questions, there are only bad answers. So don't worry about it. Ask any questions that you like. Less than equal to Z. So I will have digit underscore is equal to order of well minus order of A. What else? What else should I add to this? Why is well a string now? Oh, I'm sorry, it's not a string. It's a typo. Mistake. Thank you for correcting it. What else should I add? What is the value of A? What value do we assign to A? What digit that we want to assign to A? We want to assign it a value 10, right? Because 0 to 9 are taken by the digits, then A mean 10, B mean 11, C mean 12, and so on, right? So what should I add here? Plus. Okay, I'm looking at the chart to see, okay, plus 10, thank you very much. So now I have the digits. Now I have to let's call it decimal value, and I'll make it equal to 0. And I'll say decimal underscore value plus equal to digit underscore well times base power n. Does everybody understand what this is doing? This is doing exactly this. It's taking the digit, multiplying it with base power n. Okay. So I think that should do it. There is still a well in line 23. Oh, sorry. Yeah, thank you for pointing it out. Okay, let's see what it gives us. So it says it's 10, and we know that this indeed means 10. Okay, let's give it something interesting that we know. So let's see if it works for base 2 as well. So 1, 0, 0, 0, and give it base 2. So this should be 1, 2, 4, 8. This should be 8. Let's see if it gives us 8. Okay, it does give us that. I'm going to remove the print command so that we can see what's going on. Okay, that's nice. It seems like it's working. So what is a base 2 12? So base 2 12 is this 1 1 0 0. Let's see if we get it. Okay, so it seems to be working. However, the code is not complete. What is one bug that we might face in this code? There is a possible bug that we might encounter. Can someone tell me what that bug might be? It's not a coding bug, it's a logical bug. It's a logical error that we might encounter in this code. So something like this. Let's say if I do this, let's say I have a number A0 and I give it a base 3. Should it work? No, because the base should be bigger than the biggest digit in this number, right? So we have to put a logical test for this, something like that. So we can do a good way to do things like this is just put a flag, and before we do this, we just check that if digit underscore well is greater than base, then flag is equal to 1, and if flag is equal to 1, then print logical error, else print the number. Okay, that should probably work. Let's check. Okay, so we have also corrected this error. So that's how you do this simple code in an elegant way. The idea was that you should
learn a little bit about array indexing. You should know a little bit about instruction of logic, array flipping, and loops and conditionals. Okay, is everyone clear how to do this question? Okay, perfect. So somebody asked about the question of this Chinese puzzle, extended Chinese puzzle, which is the chickens and rabbit question. I haven't done it. I haven't tried it in code yet, but let's try it together. Okay, so let's try it together and let's see if we can come up with a good logic. You guys have to help me. So let's say that I'm going to, what are we calling them? Rabbits and chickens. So let's call it num rabbit is equal to, give me some number, let's say 8, and num underscore chicken is equal to something like, let's say 5. Why am I doing it? Because I want to generate correct data for the puzzle. How many rabbits and how many chickens are there would define what is the number of heads and feet. So number of feet would be 4 times num underscore rabbit plus 2 times num underscore chicken. So, and num underscore head would be simply num underscore rabbit plus num underscore chicken. I'm assuming this is correct. Okay, so now this is your data. So you would be given your function. So define solve underscore puzzle. It will take in num underscore head and num underscore feet. And you have to return number of cows and number of chickens and number of rabbits. Okay, so if, for example, you are given number of head, what do we know for sure? We know for sure that the number of cows has to be less than the number of. The way we hear this, we hear it about cows and chickens. So if I say cow, I mean rabbit. So that's I might make this mistake. So the number of rabbits has to be between 0 and number of heads, right? So basically, let me call this possible number of rabbits. This would be I for I in range num underscore head plus 1. Okay, so this is giving me all possible number of number of rabbits for this particular problem. And now we have to find the correct one. So to find the correct one, can I do this for well in possible underscore num underscore rabbits, do this n underscore head is equal to 4 times well plus 2 times num underscore head minus well. So basically, let me explain what I'm trying to do here. So my logic is this. You say that, okay, the number of rabbits can be 0, 1, 2, 3, 4, 5, up till the total number of heads. And whatever is not a rabbit has to be a chicken. So this is the possible number of rabbits, and this is the possible number of chickens. So the total number of heads would be this. Is it clear? Does it make sense to everyone? Okay, excellent. So we do the total, oh, sorry, this is total number of feet, sorry, feet, because I'm multiplying it with 4 and 2. Okay, and total number of head would always be satisfied. So n underscore head would be this, well, plus num underscore head minus. Well, so this is always satisfied. Okay. So then I can say, I'll say that if number of head is equal to the number of actual heads that I'm getting in my puzzle, and the number of n underscore feet is equal to the actual number of feet that I got from my puzzle, then simply return, let's return it in f string. What do I want to return? There are, well, rabbits and underscore heads minus 12 chickens. Okay. If this doesn't happen, if you don't return this, then you would have to return yes, no solution exists. Okay, thank you for correcting the error. Let me just quickly go through the logic. So basically, I'm saying that the possible rabbits are between 0 and number of heads. Then number of feet for this would be well times n head minus well, which seems fine. And number of feet, sorry, and number of head would be this. If n head is this and this is this, I think this should work. Let's have a look. Okay, sorry. So it's returning the string. I have to use this. So I'll call it print. What is it? Solve underscore puzzle and num underscore head and num underscore feet. Okay, line 11. So what is on? Yes, this is num underscore head. Okay, there are 8 rabbits and 5 chickens, which is exactly what we had given it. So let's change it. Let's make it 11. There are 11 rabbits and 5 chickens. Okay, that's fine. Now let's break the problem. Let's add a 1 to it. Now this is incorrect data. So this should say that no solution exists. So this is how you solve this puzzle. Okay. Any questions here? It's just a simple way of constructing this logic. Okay. Everyone understands what I did here?
Yes.
Okay. Perfect. Perfect. Any questions? Okay. Just I'll give one more intuition to this as to what I did. Can I do annotation? Unfortunately, I cannot do annotation on this slide. Anyway, we will look at it later. Okay. Any other questions that were particularly difficult or people find people had problem with it? We can do it. How many of you managed to solve question number 315? And was it difficult? And if you did it, how did you do it? Because that's an interesting question. It tells us about strings and string logic. So 315 is asking this. You give a question certain number, let's say 10, and it constructs a triangle for you with, sorry, it's to be odd. 11 stars at the base, then 9 stars, then 7 stars, and up till all the way up with 1 star. How many of you actually managed to do it, and how difficult it was, how easy it was? Were there any problems? Okay. Okay. Who else managed to solve it? Do you want me to give it a try? Guys, please don't be shy. Talk to me through the chat. It's fine. It's fine to say, yes, give it a try. It's fine to say that, no, we did it. It's very easy. It was perfectly fine for us. Everything is fine. Don't be shy. just talk to me so that I can feel how fast or slow I'm going. Okay. Okay. So let's give it a quick try. Let's do it quickly and see if there is any issues in it and if we can do it in an effective logical manner. So basically, what do we have? In the question, we get an n, which is, let's say, number, or let's call it triangle base. You get an odd number here. And after that, you have to construct a triangle such that the number of stars on the base are 11 and then 9 and things like that. Okay, so how would I do it? Okay, so I have to loop. If, for example, the number of star in the base are 11, I would have 6 rows code. At the bottom, it would be 11 stars, then 9, then 7, then 5, then 3, then 1. So I have to do this loop 6 times. So I have to do something like this for I in range. Underscore base 2 plus 1. By the way, if anyone did it with a better logic than this, please let me know. But this is the way how I would do it. This is an odd number. I do the integer division. So this would give me 5, and I add plus 1 to it because I want to loop it 6 times. And then I have to do two things. I have to find what is the number of stars for a particular row and what is the number of blank spaces in a particular row. Okay. So I would say that the num underscore spaces in a particular row would be, if it is 0, it means that it's the first row. So this would be triangle underscore base, which is the total number of element, minus I. This is the, okay, let me first write the number of stars. I think it's probably easier. So the number of stars is 2 times I plus 1. So in the first line, it's I is 0, so you have just 1 star. In the second row, I is 1, so you have 3 stars, and then 5 stars, and then 7 stars, and then 9 stars, and then 11 stars. Okay. The number of spaces would be the total length of the triangle minus the number of stars, integer divided by 2, because you have spaces on both sides of the star, on the right and on the left. Okay, and then we have to just write the string that we want to print. So my string is what? So you have num underscore, sorry, you have to print a space. How many repetition of this space equal to num underscore space plus. By the way, for string, if you want to repeat a string n times, you can just multiply it with n. Okay, that's one of the Python functionality. And then we have the number of stars. So you just multiply it with num underscore stars. And then on the other side also, you have num underscore spaces. So this and num underscore spaces. I'm not sure if it might be possible to remove this one and it still works, but we will check it. And then you just print it. Okay. So let's say, okay, number of stars is not defined, so I'm calling it star. So let's call it star. Okay, so it seems to work fine. So this is 1, 2, 3, 4, and the bottom one is 11. And we can give it, let's say, a larger number. It works fine. Okay, let's remove this and let's see if it still works or not. I think it should work. It should still be fine. Yeah. So that's an easy way of doing this question. But the idea is to get used to strings, how to merge strings, how to repeat strings, and how to construct this in a logical manner. Okay. Okay. So with this, I'm going to stop the discussion about yesterday's question, and we are going to discuss a little bit about object-oriented programming. So object-oriented programming is actually a set of lectures in itself. We are not going to go into all the details. We're just going to look at the very basics of object-oriented programming and just utilize the part which is helpful for us, for our applications and in using of machine learning tools. Okay. So we have used object-oriented programming in some sense. So for example, we do something like this. So let me call this my string. And let me call it this test, or let's say do something simple, fun. And then we do print my underscore string dot device, and then print. So what is this dot doing? What is this? What does this capitalized do? This is basically called a method for an object, and I'll explain what this means. Okay, so basically, I think it might be good if I share my iPad and we just discuss a little bit here before I come to code. So let me. So there are two types of programming approaches. One is called this functional approach, the procedural approach, I think. Okay, where you have certain data. Let's say in our case, we want to, let's say we have an example where we want to create a database and associated functions for a company. Okay, let's say we are opening our company. Let's call it LMH Summer School. Okay, and in this company, we have students. Okay, and each student has certain properties, which is, let's say, their registration number, their, let's say, degree, and let's say their region. Okay, and based on these three information, we have to assign a course to them. So we have a function which is called assign course. It would take in the student, it would return a course. To say, okay, give them course A or B or C. So the way we would do it right now with the things that we have studied so far, we would say that, okay, let's say that student is maybe a list. Okay, so each student is a list. Let's call this student 1. And the list has their registration number. Let's call it 001. Their degree, let's call it MS. And their region, let's call it UK. Okay, and we write a function. This function takes in this list, student ID. So the function would be there, assign course, takes in this list, it's called student data. Okay, and then it would run some code depending on whatever the condition is. Finally, returns a value A, B, C, and D depending on what the logic is. That's how we would do it. Okay, but imagine that you are in a company where associated with the student is a lot of unique variables. Okay, lots of unique variables. Let's say we want all their grades as well. All their grades up till now, all the education. Let's say we want their sports performance as well, their co-curriculars as well. So this thing of like moving in this data to a function, returning it back from a function, this becomes incredibly tricky. We can do it, but it's not a very nice approach to do it. So in object-oriented programming, what we do is we say that, okay, let's group all these things together in a manner which makes things much more feasible for us. So let me show you how we do it and what we do. So basically we say that let's create an object. Let's call it student. Okay. All the data that is related to the student is inside this object. Okay. Just consider an object as a block, as a black box. You don't know what it is. Everything that the student has, all the thing which defines the student is inside this object. Okay. So their grade, their co-curriculars, their I don't know, registration number, their name, age, everything is inside this. Okay, and that all the functions which work on the student, for example, the function which assigns them a course, the function which assigns them a new grade, the functions which assign them, let's say, a class trip, everything is inside this object as well. All the functions, all the useful functions are also present inside this. Okay, how would we write it? So basically what we want is, take the same example, student one. Let's say now student one is this object. Okay, anything that we want to use from this student, let's say their grade or maybe their age or anything, we want to access it through this dot notation. So we put a dot and we say, okay, give me the grade of student one. So we'll say student one dot grade. That's what we want. We want to run the useful functions on this. Let's say we want to say, I want to find which class student one should go to. I just want to write student one dot assign class. I don't pass any data to it because it's part of this object which has access to all this data already. And that's basically what we do when we say my string dot capitalize. Okay, so string is an object. My string is an object. It has the string value, whatever it is. In this case, it was Khan. And then it has a function which is capitalize. Capitalize has access to this data because it's part of this object. And you just call it like this, and it automatically capitalizes it for you. Okay, that's the idea of object-oriented programming, to make a group, to group all the data and the functions that you want to use in a single object, hence the name object-oriented programming. Some notational thing, these variables, these are called attributes of the object, and these functions, these are called methods. Okay, attributes and methods. Now let's see a little bit about how object-oriented programming works in Python. How do we do it? And what are any intricacies that we would do? The details of this are in chapter 4, which is very detailed. I would suggest you guys give it a very good read. Go through all the examples and it would explain the concepts in a lot of detail. But let me just give you guys a quick overview of how things are. Share my screen. Okay, so let me remove this. So objects, we have defined what an object is. Object is an entity which has the data and the function associated with that entity inside one, well, I'll call it object. But so student, we do not have just one student, my students. We can have multiple students. We want to group all of these objects together, which are similar, into something which is called a class. Okay, so let me write a class, and let's say students. In Python, you can just define a class by simply writing class and the name of your class. Okay, and then the first thing that we need to do in any class, to use a class in an effective manner, is to write a constructor. Okay, I'll explain what a constructor is. So I'll call it self, and let's say registration and name. And let me call it self.name is equal to name, and self sorry, and self.reg is equal to reg. And now let me define something like student1. Student1, I'll call it students. It's good practice to write it like this so that you can differentiate it from your objects. And let's say registration is 001 and name is Khan. Print student underscore one dot name. Let's run it. So let's, sorry, this is a string. Can somebody tell me what the error is? Oh, yes, that's probably the issue. Yeah. Okay, so basically, let me explain what it is. So like I said, student is an object which has some attributes, but you might want multiple instances of that, that object. There would be a student one, there would be a student two, there would be a student three. So all of them have a fixed template, right? Each of them has to have a registration number, each of them has to have a name. But we want to create a kind of code which can produce all these different objects. And this is called a class. So a class, every instance of a class is an object. Every time you define an instance of this class, that would be an object. And of course, we want to have different instances mean different things. So student one would be something, student two would be something else, student three would be something else. In order to provide this interface between your object and the class template, we use this function called init, which is a constructor. So basically, let me tell you what this code is doing. So every time you write this thing where you define an instance of your class, so let me copy it and, sorry, let's call it student two, and let's call it John. Okay, and let's print student. Okay, so every time this you call this, it would call this init function. Okay, and what would it pass to it? The first thing that it passed to it is this name, the object itself. Okay, so self would have the object itself. Self means the object itself. The second element would go to reg. The third element would go to name. Okay, and inside this, what I'm saying is that object.name is name and object.reg is reg. So when this line runs, when I run line 8, what this means is student1.name is Khan, student1.reg is 1. Let's make it 2. When this line runs, it would say that student2.name is John and student2.reg is reg. Does everybody understand what this init constructor is doing? So basically, every time you, okay, perfect. Okay, that's good. I don't need to explain it more. Okay, so that's basically the way you would do it. And then you can, of course, write different functions inside this. So let's say define, let's call it, what was it, assign class. and then you pass it the object itself. So if it has the object, it has all the data associated with this object. So I can write a logic something like that, that if self dot name is equal to Han, return A. Of course, your logic would be much more complex than this, but this is just to give you an example that you can do things like this. Is John return B. So now we are assigning classes, and let's see if we can do. So I want to print student1 dot assign class, and let's see what happens. So it is assigning a class A to Han, and in fact, let's get here. So let me copy the name. Let's run it. So Han is assigned A, and John is assigned B. Remember that I didn't pass it any data here. There isn't any flow of data because data is automatically accessible to it inside the body of the object. Whenever I pass it self, I find it all the properties and attributes associated with self. So every function, every data, everything which is inside student1 is passed to this function. So that's the advantage of using object-oriented programming. You don't need to do this explicit passing of data. You can, of course, have a ton of parameters. It doesn't have to be just two. You can have lots of attributes here. Okay, and then you can use them inside this function. You can write very complex function which takes in these attributes and do something with them. Okay, so that's the advantage of using object-oriented programming. With this, I'm going to stop the lecture part of it for today. Go through the exercise of object-oriented programming. Particularly, I'm interested that you guys should give a try to question number, let me just open it, 4.2 and 4.3, okay? Maybe 4.4 as well. 4.2, 4.3, 4.4, if you guys can do it, that would be great, okay? But read the chapter because the chapter has everything. It's very detailed. All the information is there. Read the chapter and let me know what you think. By the way, for yesterday's lecture, the video and the slides are on the website. Okay, so I use it. If you want to do it, I'll do the same for today's lecture. After the lecture is over, I'll upload the videos and the presentation and any other related material. Any questions about what you guys have to do? Okay, so I'm assuming everything is clear. Take around an hour. Let's try to do it till 11. Try to solve these object-oriented programming questions. At 11:30, we will give them a try. We'll try to do them together and just have a quick overview of NumPy, just quickly doing some simple examples of NumPy. And after that, for tomorrow, we will be set for linear regression. We will be actually coding some simple examples of linear regression. Okay. I am available in the chat. If you guys have any questions, somebody has any confusion, please let me know, ask your questions, and I'll be more than glad to help you guys. Thank you. So I want to do two things before I leave you guys to do the rest of the exercises. Let me just adjust my. So one is, I think it's exercise 4.3, object-oriented programming exercise for grid example. And the other is NumPy broadcasting example. Something like 9.4 or something like that. Let me just open the machine to have a look at which question it is. This is 9.8. Okay. These are important because they have some important points that I want you guys to understand. By the way, is everyone with us? Just put a simple yes in the chat so that I know how many people are listening and how many people are with us. Perfect. Thank you very much. Okay. Okay. So the question is this. In 4.3, what we want is we want to have a rectangular grid. Okay. The user would give the coordinate x0 and 0y. So this x and y would be given by user. Okay. You would define the grid. After that, you would be given points x, y, and r, where x, y would be center of the circle, r would be the radius of the circle. And if you can place this circle without it intersecting with any other circle and completely in the grid, you would output a true and place the circle. If, for example, the circle was, let's say you were given a circle, which is probably like this, it has an intersection with the red circle, then you won't place it and you would output a false. And you won't place it. This won't be placed. Okay? And this, the number of circles can be any number. So this example is just to show that how easy things are in object-oriented programming. If you do it with functional way, this would become a mess quite quickly. You would see that it's you would have to handle each of these properties separately, and then it becomes a mess. And of course, you don't need to have just one grid. You can have n number of grids. I can give you a grid 1, which is a certain size, and then a grid 2, which is a certain size, and a grid 3, which is a certain size. But we will see that this is much more easy to do in object-oriented programming. The main logic that we would use to see if the circle is inside the grid, it's actually quite easy. If I know the center of the circle x, y, and its radius, how can I make sure that it's entirely inside the grid? Can you guys tell me the equations that I would want to be satisfied in order for the circle to be completely inside the grid? So if the center of the circle is x and y and the radius is r, what is the maximum value of x that is possible to be inside this circle? I'm looking at the chat for your answers. So basically, I'm asking you guys this: maximize x such that x naught squared plus y naught squared is less than r squared. What is the maximum value of x? Sorry, x minus x naught whole squared and y minus y naught whole squared is less than r squared. That's going to be x plus r. That's the maximum value of x that's possible. So just simply see which is the furthest point in the x direction. It's this, right? If you go completely in the x direction, and since the radius is r, this value can be x plus r maximum. Here in this example, it's x naught plus r. Okay, everyone understands what I'm saying? The maximum value for a circle which center is at x and y, and its radius is r. The maximum value of x, which lies inside the circle, is x plus r. Is everyone clear on this? If not, please say no, and we can. Okay. Okay. If this is clear, then everything else falls into place quite simply. We have to just check this. The logic would be that x plus r is less than, I'll call it x lim, the dimension of the grid. So this I'll call x lim, and this I'll call ylm to differentiate it from x and y. And then x minus r is greater than 0, and y plus r is less than ylim, and y minus r is less than, is greater than 0. This means that the circle is inside the grid. One condition is satisfied. How do I make sure that two circles do not intersect? Let's say this is circle x0, y0, and r. This is another circle x1, y1, and r1. Let's call it r0. How do I ensure that these circles do not intersect? What conditions should be satisfied for the two circles to not intersect? I want to see what is the difference between their center point. I want to relate it to the distance from their center points. The distance from their center point should be what compared to the sum of their radius. So I want this x0 minus x1 whole square plus y0 minus y1 whole square is something r0 plus r1 whole square. Should it be greater or less for the circles to not intersect? Greater than, yeah. It should be greater than. If it's greater than and even equal to, the circles would not intersect. They would intersect at the boundary, but let's assume that intersection at the boundary in our particular application means no intersection. Okay, so these are the two conditions that we would have to do in order to make sure that the circles do not intersect. Let's keep this discussion to the side. We will come back to it once we go to coding. I just wanted to show you it on the paper before I code it. Okay. Let's come back to the example of NumPy broadcasting, which is 9.8. The size 9.8. So this is basically from one of the research problem that we were tackling. So we wanted to construct some energy, which came into this very nested form. So basically what you want to do is this. You have an image. It has length, width, and certain number of channels. For the time being, let's assume that the channel is 1. Okay. So image typically have 3 channels, a red channel, a green channel, and a blue channel. For now, let's assume that there is just 1 channel. And then you have certain mask. Mask. So mask is basically just a 1, 0 value. The value is 1 here, and the value is 0 here. So basically, it represents certain object. Let's say it represents a cat. Okay. What we want to do is, we want to see, of course, mask is the same size as the image. It's also length time. What we want to do is, we want to take the element-wise product of the mask and the image and calculate the average value in that. So basically what I want to do is, inside this mask region, I want to take all the pixels in the image. So I'm just going to place the mask here. Okay, these are the values of mask is 1. I want to find all the values in the image, add that up and find its average. So basically I call it A. And A is basically this. It's the summation over length and width over all the pixels, okay, of what I of, let me just use some better notation so that there is no confusion. So I'll call it L in, it's not a nice notation. So let me take this, clear this up. And let me write it like this. Okay, so the number of rows are in a set L, where it's from 0 to some 0, 1, 2, 3, some L naught, where L naught is the length. Okay, the columns are in set W, 0, 1, 2, up till W naught. So L naught and W naught represent the number of columns and rows in an image. Okay, and 0, 1, 2, 3, these are the possible values for the rows and columns. So for example, if you want to look at 0th row, it might be this. Then you want to look at row 1, it might be this, row 2, and so on. And this would be L naught row, or the other way around. So just give you an idea. So the rows come from this set and the columns come from this set. And what I want to do is, I want to do a summation where I can, when I have all the rows in L, all the columns in W, and I want to take element-wise product of I, L, W plus multiplied with mask of LW. I want to add all of them up, and then I want to divide it by L in L, W in W of mask L, comma W. Okay, this would be A. What does this mean? Basically, what it means is that I'm trying to find the average value of the image inside this patch. That's exactly what it's doing. So this would zero out the image outside the mask, because mask is 1 in the foreground, it's 0 in the background. So anything in the background would be removed. You would just have the foreground, right? With this thing, the product of this would be just the foreground. And you add it, you would get the sum of all the pixels in the foreground. Okay, but then you want to average it just for the foreground. So you add all the elements of the mask, which would just give you the number of pixels in the foreground, and you get the average value. Does it make sense to everyone, what I'm doing here? If not, please ask questions. Okay, I'm looking at the chat. So if there are any confusion, just please say repeat, and I'll repeat it again. Or it's not clear, just put a simple no, I will repeat it again. If it's clear, just put a yes, and I can move forward. And don't be shy, there is no need to be shy. You can ask as many questions as you want. I don't mind. Okay. Other people, is it clear or it's not clear? Should I move forward? Okay, so I'll assume that there are no questions. Let me just move forward. So how can I do it in code with the tools that we have studied so far? Well, we can do something very simple. We can say that for L in the set L, for W in the list W, let's call it total. And we say that total should be equal to image at LW times mask at LW. So this would go over each pixel. If the pixel is in the foreground, if the mask value is equal to 1, it would add it, otherwise it would zero it out, right? So you would get this total. And you can also, in the same code, you can also sum up the mask. You can say that total underscore mask, this is plus equal to total underscore mask plus equal to mask. So you will get the total of the mask, all the pixels in the foreground of mask, and the sum of all the values in the image which are in the foreground of the mask. And then after that, you can just say the total divided equal to mask. That would give you the average value of A. And then you can do the rest of the calculation. So basically the calculation that you want to do is, you want to subtract image minus A whole square and add it in the foreground only. So it's mask foreground. And then you do the same operation for the background as well. So background, if this is foreground for mask, that's where mask is 1, this is foreground. The background would be just, this would become 1 and this would become 0, right? You want to do the same thing for background and you want to get the total value for that. So you can see that this can be done in for loops. I will do it exactly in the code, but this is just to give you guys an idea of what you want to do. And we will show why this is a bad idea and what is an effective way of doing it. So bear with me. Let me solve the object-oriented programming question first, and then we'll come to this. Okay, but I just wanted to show you the mathematics because it is indeed a little complex, but complex in writing, and mentally it's very easy. Basically, you want to calculate the average value of a region in the image and subtract the average value from each pixel in the image in that foreground and add the sum of their squares. Okay. Similarly, you do it for the background. You calculate the average value of the image in the background. You subtract this average value for each pixel in the background, and then sum the square of all these values. And we will see what is the understanding of this. Why do we need it? So the idea was to, from a machine learning point of view, what we were trying to do is for an image, let's say if there is a cat here and some background here, we wanted to learn some descriptor for the cat, which is constant on the entire cat. It looks at generates some feature of the cat, and then this A does not change. Everywhere where there is A, it has a constant value or a close to constant value. And we want to learn another A, let's call it a complement for the background, which stays constant on the background. These things are unknown. They come from a neural network, but this was our energy function. So our energy function was U minus A whole square on R plus U minus A complement whole square in our complement, and we were minimizing it. Okay, and if you do it with for loops, there are a ton of problems. You need to broadcast it so that you can do it effectively. So we'll show how do we do the broadcasting. Okay, so let me share my screen and let's look at some codes. So, okay, first let's do the object-oriented programming. By the way, guys, you have to help me. I'm doing it on the go. I have solved this question before, but I might still make some error. So, object-oriented programming example. This is 4.3, something like that. Okay. So the first thing that I need is I need to define a class for this grid. So I'll call it class. Again, we want to use camel-case notation for classes because differentiate them from objects. Okay. What is the constructor? How should the constructor look? The constructor takes two variables, x and y, and defines a grid from this. So what should be the definition of the constructor? What should be the variables here? And what should I do here? What is the first element of the constructor? What do we call it? Self xy, okay. So by the way, you can call it anything. You can call it a gun if you want. It would still be fine. You have to just call it gun everywhere. But the convention is to call it self. Okay, so we'll call it self. Okay, so let's call this xlim and ylim like we did in our notes. And xlim would be x and ylim would be y. Okay, I need to do another thing at initialization. I want to construct or start keeping track of the circles that have been placed on the grid. So what would be an efficient way of keeping track of the circles? How is our circle represented in our notation? Since we are in 2D, the circle is represented by three variables, x, y, and r. So we have to keep track of these three variables, x, y, and r. How can we do it effectively? How can we store it? Like, what would you guys suggest we do in order to keep track of the circles that have been placed on the grid so far? Of the data structures that we have, containers that we have studied so far, which container would you guys want to use? A list, right? List seems like the most obvious choice. So I'll define a list. I'll call it list underscore circles. And I'll make it an empty list because by default, there are no circles on the grid. And then I need a function, let's call it place underscore circle. This would help me place the circle on my grid. Okay. Of course, all circles are not placed on the grid, certain conditions have to be met for a circle to be placed on the grid. What are the conditions? The first condition is that the circle has to be inside, completely inside the grid. So we have to do this. Okay, I've made a mistake. This needs to get all the object itself. Okay, it needs to have x lim, y lim, and all the circles that have been placed so far. So then what do I need to do? I need to check if the circle is inside the grid completely. So this would be something like this: if self dot okay, give me a second. This takes something else as well. This has to take in the circle x, y, and r, right? Because it will get a circle in order to decide to place it on the grid. Okay. So let's see, what do we have to do? So we have to check that x plus r is less than self dot xlim, and x minus r is greater than 0, and y plus r is less than self dot ylim, and y minus r is greater than 0. So basically, it's easier to see when the conditions are not met because we are using a flag 0, which means that all the conditions are met. So I'm going to reverse them. So if any of the conditions are not met, so if this is not met, or this is not met, or this is not met, or this is not met, then it means that the circle should not be placed. So I'll make the flag equal to 1. It means that the circle cannot completely be inside the grid. Okay, so flag equal to 1 means don't place the circle. Is it clear what I'm doing with the flag?
Yes.
Okay, perfect. Thank you very much. I'm looking at the chat. So if you put yes in the chat, that would work absolutely fine. Now, after that, we have to do something. We have to check that there is no intersection with any previous circles. So I will do something like this. I'll say that for I in range of what? Length of self dot list circles. So I want to go on every element in the list dot circles. List dot circles, like I said, contain the circles that have already been placed. Okay. And what I want to do is this list contains tuples of x, y, and r. You will show what I mean by this. So in order for two circles to not intersect, we saw that the distance between their centers have to be greater than the sum of radius. If they intersect, the conditions would be the other way around. So it would be this: if self dot list underscore circle I. So I'm looking at the ith circle that has been placed so far. It would go over all the elements of the list. I'm looking at the ith element in this iteration. The first element of this tuple would be x, the x component of my circle. So I want this square plus self dot underscore circles I 1 minus y square. So this is the difference of the x component and the y component. If it's greater than the sum of radius, then there is no intersection. So we want to check if it's less than this. And we would say that this should be self dot list underscore circles I 2 plus r whole square. If this is less than this, it means that there is an intersection and we have to set the flag to 1. If flag is equal to 0, what do I need to do? I need to place the circle, which means that this has to be appended to this list, right? So then I have to do that self dot list underscore circles dot append. And I will append, like I said, we want the list to have tuples, X, Y, and R. So this is a tuple with 3 components, X, Y, and R. The X component, the X and Y components of the position and the radius. And then I have to print true. And if flag is equal to 1, print. I can use an else as well, but this is just for clean code. I'm assuming it should be fine. Let's see if there are any errors. Okay, without error. Why about this? Okay, so let's create a grid and let's see if it works. So I will create my grid and I'll call the grid function and I will give it, let's say 10 and 10. Then I'll say grid dot place circle and I want a circle to be placed at 5, 5 with a radius of 2. This should be good. Then because this is the first circle, then I want to place a circle at, let's say, 8, 8, and a radius of 2. This should not be placed because it would have an intersection with the 5, 5 circle. Hopefully, I'm assuming that it would. We have to think of it. In fact, let's make it a little larger. Now it definitely has an intersection. Okay, and let's check the other condition as well, which is outside the grid. So let's give it something like 1, 1, and 5. This should also not be placed because it is outside the grid. Okay, so let's run it and let's see what happens. Okay, so the first one is true, the second one is false, and the third one is false, which is exactly what we expect. You will probably have a problem for the first circle. I don't know. Put it in the comment if you think something is wrong with the code and I'll have a look, but I think it should be fine. Let's place another circle, another correct one, just to make sure that it can still place correct circles. So let's make it, what do you want? Let's say 2, 2, and 1. This should be fine. So okay, let's place underscore circle. Okay, so it seems fine. At least to me, I don't know if grid underscore circles. And we can have a look at the list of the circles that have been placed so far. So there has been a circle placed at 5, 5, 2, a circle placed at 2, 2, 1. Okay. One of the things that I want you guys to see is this. Okay, this is like an interesting thing. So the ith element, when you extract the ith element out of your list, it's a tuple. Then you extract the 0th element of that tuple. So try to understand it. If it's a list inside a list inside a list inside a list, you can use like this nested type of indexing as well. Okay, is it clear to everyone that I've done here? Are there any questions? Guys, communicate a little with me. Just please type in the chat. Yes, no, we're happy, we are sad, anything, but talk so that I can, because I cannot see your faces, you're not in the class, so I need some interaction. Can you explain the tuples again? Yeah, of course. So tuples are, just like lists, tuples are a type of container. So y is equal to, let's say, something 1, 2, 3. One of the main difference between lists and tuples are that tuples are immutable. So once you define it, you probably cannot do something like this, y of 0 is equal to 5. So this would not work. These are immutable. Once they're defined, you cannot change them. Okay, I think that's why probably, otherwise they're just like lists. But they're mutable. I don't know what are the other major differences between them. The main differences in their definition, they are defined with parentheses rather than the square brackets, and they are immutable. You cannot change them once they're defined, which means that probably you cannot change their length, you cannot add other elements to it, and things like that. But go through the handbook, it would have some further explanation, because from the top of my head, I can think of these major differences right now, but the handbook would have more information about this. Okay, what else? Any other questions? Any other suggestions? Comments? Anything? But yeah. So I want to see 29 yeses in the chat before I move. Is everything clear? Everyone has to put a yes in the chat before I move. Okay. 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 It's still not 29. Yes. Go ahead. Okay. Yes. So can we use else condition in line 25? Yes, we can definitely use else condition in line 25. So we can do exactly like this. We can say, because we know exactly there are just two values of this. So this should work exactly fine. There shouldn't be any issues. Okay. Okay, so it means that everyone can listen to me and everyone is attentive. Let's go to the next example, which is actually the one that I like more. So I'm going to just quickly import the libraries. Okay. So let me just copy the data for it. So I have it somewhere here, yes. I'll do the simple example first, and then we'll make it a little complicated and we'll see how it becomes more challenging. So let's take the simple example. We have an image which is two-dimensional, and then a mask which is two-dimensional. So the first thing that I want to do is I want to, for each unique value of mask, I want to find the value of A. So again, I'm doing this for the first time with you. You guys have to help me. Okay. So first I need to find the unique values of mask. So I can use np.unique. This would return all the unique values of mask. Okay. So then I can say for m in MOL, which means that for each value of mask, what do I need to do? I need to take the product of image with the mask. So I'll say image times mask is equal to m. Let's just see that this is indeed what we want it to be. Figure. By the way, if I'm using some new commands which are not clear, please ask about them in the chat and I will explain. Okay, unique. Okay, so this is the image, this is the mask. Okay, and mistake. This is plt.imshow, not plots. Plot is for linear data. Okay, so that's exactly what we expect, right? You take the product of mask and image, you will get these things. Okay. Now, in order to calculate the values of A, what we need to do is we need to iterate over each element, right? So I need to get the number of rows, the number of columns. In fact, let me call them rows, rows and columns. And for now, we don't have channels, so I'll just use np.shape, or I can do directly the shape. This would return the rows and columns. Then I'll say for R in range rows and for C in range of columns, because we have to go through each row and column of this image and add them up. So I'll call it total equal to 0 and total underscore mask is equal to 0. And we will say total plus equal to see, and total underscore mask plus equal to mask RNC. Okay, so you are adding all the values of images which are relevant to you and all the images, all the values of mask which are relevant to you. We don't want to do it for the entire image, of course, so this has to be multiplied with foreground, which is this. And this also has to be multiplied with the foreground, which has to be this. It would still be the same because I think it doesn't change. If you multiply mask with mask, it will just be mask. Okay, and I think that should really do it. Then I have to do A is equal to total divided by total underscore mask. Let's just print it and see what it is. I'm going to remove the plots. Oh, sorry, I have to sum it. So this has to be empty.sum. There is an issue. This is mask. See. I don't need this. Okay, I have to do it outside the loop because I want to add all of this and then do it. Okay, 0.5 seems fine. That's exactly what we expect. What is this 0? What am I printing? Okay, there are two regions, so that's fine. Okay, so this is for foreground. I have to do the same for background. Let me think what I need to do. So how do I do it in the for loop? So basically what happens is that first it takes m equal to 0 and goes through this, calculate a, which of course turns out to be just 0 because we are multiplying it with this. And then I think probably I just don't need this. I can remove this one, this for loop, and just do it like this. I'll call this A. This. Okay, that's fine. Now I have to do it for background. So for background, I will do this. I'll just copy the entire thing, paste it here again, and this would be 1 minus mask, and this would be 1 minus mask. This because for the foreground, if the foreground is 1, for the background, if you want to get the mask for the background, you just subtract the mask from 1. It would make the background equal to 1, the foreground equal to 0. So 1 minus mask, this should work. And I'll, rather than calling it A, I'll call it a complement. Okay, so that's fine. We have both A and a complement. Now we need to take the difference from the image times mask and A and sum it up in foreground and background. So then if we do this, we will do this. Let's do it here. So this would be I minus A whole square times mask and np.sum. So I'll call it while1, and I'll call it I'll call this well2, and this would be np.sum I minus a complement times 1 minus mask. And then I'll just do well1 plus well2. And let's see what it turns out to be. 256, I think this is fine. That's what I expected. So we have 32 times 32. Let me just double check. I specifically designed this problem so that the values are such that we can easily interpret them. Times 0.5. This should be 512 divided by 2. Why do we have a divided by 2? Because we have 32 by 32 and, oh, sorry, it's 0.25. It's not this. Okay. So this is exactly what we expect. It should be 2. I'll explain how I come with this number. But I designed this problem specifically so that we can debug and make sure that this is actually the correct number. So you can see that this is a very ugly code. I don't like it at all. And the thing is, image does not have to have one channel. It can have multiple channels, right? You can have, let's say, 3 channels. Then it would become even more tricky. And you would have to have a loop here on the number of channels as well. So not a good way to do it. So let's look at what broadcasting is. Okay, let me try to do the same thing with broadcasting and then explain each step and show why it's actually helpful. So let me just copy this part. And by the way, did you guys read through the broadcasting section of NumPy? Chapter 9. If no, just write no, and I'll give a quick introduction of what broadcasting is. Okay. So let me just share my screen for 1 second and explain what broadcasting is. So in NumPy, broadcasting is actually fairly easy to understand. So what happens is that there are some metrics condition for us. Just please go through the NumPy broadcasting section. But what we would use today primarily is this aspect of NumPy broadcasting. Let's say you have an array, or it's a NumPy array, of course, which has a size of 32, 32, and 3, which is our image. So, okay. And then you have a mask, which of course had a size of 32 times 32 times 2, because you have a foreground and background, right? So you had 2 regions. This, by the way, does not need to be 2. You can have multiple objects in an image. You can have tens of them and 15 of them or 20 of them. Then you have to write a for loop for each one of them, which is annoying. It is not a very nice thing to do. So what we want to do is we want to multiply each one of these masks with each of these channels and try to find the sum of our energy function that we had, right? So basically the total combinations would be 6, right? 3 times 2. So you would have 2 of these masks multiplied with each of these channels. You would have 6 possible combinations of this. In NumPy, if you want to get all combinations of 2 arrays around a certain dimension, what you need to do is something very simple. You just need to reshape this array into this shape. 32 times 32 times 2 times 1. Okay. What NumPy, whenever it finds a 1 in an array, it automatically copies it equivalent to this number of times. Okay. So it will take the image and make 2 copies of it. All 3 channels make 2 copies of it. And similarly, it will look at this, it will take this mask and make 3 copies of it. So basically what I'm saying is, let's try to do this and see what happens. So let's say this is my image. I'm going to make it a volume to make sure that, to show that this has 3 channels. And I'll make my mask in a different color. Sorry. So this is mask, and this is image. So what it does is that when it looks at the image and sees that when you take their product, I'm talking about this multiplication, when it sees that it is multiplied by 2, it will take the image and make 2 copies of it. Exactly identical copy along this dimension. Okay. Similarly, when the mask sees that there is a 3 there, it would make 3 copies of the mask. So 3 copies of the mask, 1, 2, and 3. And then it takes individual products of all 3 of them with all 2 of them. So what do you get? You get 6 combinations. So basically each mask is multiplied with each channel of the image because of this broadcasting. Inserting 1 where you want the error to be copied nth time, where n is the corresponding element in the second array. Does it make sense to everyone? I know it's a bit tricky to understand it well in the beginning, but the idea is just think that whenever you encounter a 1 in one of the arrays that's being broadcasted, it would copy it equal to n number of times, where n is the same element in the second array. Does it make sense? Okay. Okay. Want to see at least a few more yeses before I move forward. Can you write this in code? Yes, of course, we'll write the broadcasting in code. Okay. Sure. So let me share my screen. Okay. So the first thing that we want to do is, we don't need this. Let me just run it to get my data. Okay, I have an image which has 3 channels. I have a mask which is 1 channel. The first thing that I need to do, because I'm using broadcasting, I want to get the complement of the mask as well. So I'll call it mask C, which is mask complement, which is 1 minus mask. And then I'll stack it. I'll make an NumPy array. So I'll call it mask underscore stacked. And I will say that use np.stack. Take the mask C, and stack them along second axis. So stack basically takes this one mask which is 2 by 2, another mask C which is 2 by 2, put them on top of each other along the dimension 2. You can make it along any dimension. I'm particularly doing it along the dimension 2. So then I just print its shape just to make sure that things are in order. Okay, and at the same time, I'll print the shape of the image. Okay, so this is 32 times 32 times 2, and this is 32 times 32 times 3, which is exactly what we expect. Now, we want each element of the mask to be multiplied with each element of the image. Okay, so we need to, for this to happen, we need to do this broadcasting, and that we would do like this. We would say that, okay, let's insert new axis in mask stack. So let's say that mask stack is, you take it as is, then insert a new axis at one position before the end. And similarly, you do it for image. I'll call it image underscore stack. Image, you take its first dimension, second dimension, third dimension, and in the last dimension, you add a new axis. And now let's look at their shape. Print image underscore stack dot shape and print, sorry, mask underscore stack shape. So let's look at their shapes. And that's exactly what you want, right? Image is 32 times 32 times 3 times 1. And mask is 32 times 32 times 1 times 2. Okay. Now let's see if we can multiply them and what would be the shape of the the output. Okay. So I'll call it I, and I would be just image stack multiply by mask stack. Okay, I'm going to remove this and I'm going to look at this shape, print I dot shape. And you can see that it's 3 times 2, which means that each image is multiplied by each mask. Okay? So 3 times 2 means that you have a six combinations of these, which is exactly what we wanted. Each image multiplied with each mask. Okay? Does it make sense to everyone? Okay, excellent. Now we want to calculate A. What is A? A is the sum of each channel along first 2 dimensions, the rows and columns. So I can say np.sum I x is equal to 0 and 1. You can specify which axis to sum along. In this case, I want to sum along the first 2 dimensions and not the second and third dimension. So there is the first element of NumPy is 0. So when I say the first dimension, I mean the 0th index. Okay, but then we have to normalize it with the sum of the mask. So we have to do np.sum, and this is going to be mask.stack, and yes, again, x is equal to 0 and 1. I need one other thing, which is keep dims equal to true. I'll explain what this is. And I need it here as well. Keep dims equal to true. Okay, so one thing which is interesting to note with np-sum is this. So let me generate an array at random. So this is np.random dot random, I'm assuming, and I want to give it a shape, let's say 3 times 4 times 5. Print x.shape. This is a random array which has a shape of 3 times 4 times 5. Now if I do this, let me call this y is equal to np.sum of x. What do you think would be the shape of y? Print y.shape. What do we expect the shape to be? Any guesses? It's adding all the elements of y. It should be a scalar, right? It's just a number, yeah. Should be a scalar. So there is no, it's not an array. It's just giving you just a number, okay? What if I do this? What if I say that then, it's x is equal to 0. What do you think would be the shape now? No, the shape. I need the exact shape, like 4 times 5, 1 times 2, 3 times 4. What would be the shape? So you're adding along the first dimension. I'm assuming this dimension would go away. I'm expecting the size to be 4 times 5. Hopefully that's going to be the shape. Exactly. So the first dimension is gone because you have added along this, and you get 4 times 5. Now, if you put keep dims equal to true, keep dims equal to true, now what would be the shape? The shape would be this. Now, can you tell me why is this good? Why do we like this one here? What is the advantage that we can get because of this one? Something that we just discussed like 10 minutes ago. broadcasting, because then we can broadcast along this. So imagine you have this, okay? Imagine you have our case where you have 32 times 32 times 3 times 2. Now you add them along the first two dimension. Okay, you add along the first two dimension, what would you get? You would get 3 times 2. If you take their difference, it would give an error, right? It would say that, oh, these are not compatible. But if you put keep them equal to true, the size would be 1 times 1 times 3 times 2. And now you can use broadcasting, because now it would look at this, it would see that this is 32, it would copy it 32 times, and it would copy this 32 times, and you can easily calculate the difference. Does it make sense? So the keep them true is actually very beneficial for broadcasting. It helps you, it makes your life very easy when you want to broadcast. I want to see at least some guesses in the chat before I proceed. Okay, is it clear to everyone? Come on, guys, you have to talk to me. Yes, please. I cannot be the only one talking all the time. You guys have to talk back to me. Okay. So now this is done. Let's just print the values of A and let's see what it is. Okay, what's the error? There's no attribute stack. I'm sorry, this is mask underscore stack. Okay, so that's exactly what we expect. That's fine. Now we want to do the difference and then sum it up. So we have to find the difference of, let's call it total. What is total? Total would be I minus A whole square, but only in the mask stack, and then you sum it all up, and p dot sum, and that should do, right? I'm hoping that that should be fine. Print total this and 768. Let's just make sure that that's the case. 256 multiplied by 3. And that's indeed the right number, 768. Why do we get 768 instead of 256? Because I increased the channel to 3. Instead of making the channel 1, I made the channel 3. So now you see this entire code, there isn't a single for loop in this. Okay. One thing which we didn't discuss is that for loops are quite slow. Broadcasting is very fast. So this is the full code. We have more than one channel. We have two, actually we iterate over the masks and the channels and each pixel of the image. So if you want to do it with for loops, you would have 4 for loops. Here we don't have a single for loop, and it runs like a charm. It's very clean, very elegant. That's the beauty of broadcasting. Okay, so do this example by yourself. Try to understand the concept of broadcasting. If there are any questions, please ask them. I'm available in the chat. Hopefully this was clear. I'll upload the video as well after the lecture, so that you can actually revisit this and see if there are any questions, anything that I've missed, and catch up with the concept. Just a simple 1, 2, 3, 4, 5 in the chat. From 1 to 5, how clear is broadcasting to you guys now? And don't be shy. If it's -5, even that is fine. Doesn't matter. If you don't want to send a message to everyone, just send it to me privately. Don't send a message to everyone. But please let me know how clear things are so that I can adjust my speed accordingly. Because now we are going to really take off the machine learning concepts. I want the programming side to be stable so that we can actually code things. Okay, thank you. So please kindly put in the chat how much you understand and how much more work you need. Okay, just put a number between 1 and 5. Thank you.